we've got beautiful blue skies, 70-degree weather. It should be an awesome day for a launch. And we've got some really exciting stuff planned for you guys today. So we are heading now to actually see the vehicle. The vehicle went vertical, I believe it was around 3 or 4 this morning. So as we drive onto properties, you'll see our SpaceX facilities, and then most importantly, you'll see the beautiful Falcon 9 rocket out on the pad.
Start this countdown at about 2.5 seconds. The engines will come up to full power. We're thrusting, and then we release at T0.
15 seconds before the launch, my heart rate is getting fast, and my brain is only with the rocket now. And at this time, I am start brain gut.
And at the last few seconds, you feel, is it gonna go? Is it gonna go?
Kind of worry.
Falcon 9 configured for flight.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Liftoff.
In 2010, the Qatar satellite company, SHALE-SAT, was established to manage and develop a sustainable national satellite industry, entering into a strategic partnership with Eutelsat to operate a high-capacity satellite for Qatar's broadcasting, telecommunication and internet services. And Space Systems Loral was selected to build the first high-performance satellite, SHALE-1. It would take 3 years to build and weigh approximately 6 tons, eventually orbiting 36,000 kilometers above the Earth's surface. In 2012, Arianespace was selected to launch SHALE-1 from the French Guiana spaceport. And SHALE-1 entered into service on Qatar National Day 2013.
After the successful launch of SHALE-1, it was clear there is a high demand and there is a need to continue the successful story of SHALE-1. That's why we decided to go with SHALE-2. Building a satellite and the manufacture of satellite is complicated. It was really not easy to bring different nationalities, different languages, different cultures, to bring them in one team. We start our story and the selection of the partners of SHALE-2 in terms of manufacture, in terms of launching, and in terms of insurance. The design, testing. It was a lengthy process. We went through many discussion and negotiation. Finally, we decided to go with Mitsubishi Electric, Milco. At the beginning, it was a surprise for the satellite industry. Why not the usual manufacturers like European and the American? I told them, listen, it was a clear process. It was an open tender. It was a commercial and technical criteria, and then we decided to go with the best.
三菱電機では、1960年代から宇宙事業をスタートしており、これまでに500以上の衛星プロジェクトに参加してまいりました。そのような実績と衛星の信頼性を SHALE-SAT 社も評価していただいたものと思っております。
この衛星の工事が始まりまして、300人以上の関係者が携わってまいりました。また50人以上の設計者が直接設計に携わってきました。
最初のコンセプトメイキング、構想設計の段階からもう2014年にスタートして、衛星の組み上げ試験完成に至るまで2018年4年間の期間を要しています。やり取りするっていうところが難しかったことの一つですし、SHALE-SAT-2 のお客さんもカタールということで、カタールとつないで、 会議をするときには時差も考えなきゃいけない
とは言いながらやはり両者のですね、コラボレーションというものは必要でございますので、SLSAT およびメルコがですね一つのチームとなってこの衛星の設計製造に関わってまいりました。
衛星の製造プロセスですが、簡単に申し上げますと、最初の設計段階、システム、サブシステム、コンポーネントの設計段階から各コンポーネントの製造段階、製造試験をやりまして、それをサブシステムで組み上げてまた試験をし、それを今度システム衛星全体に組み上げてまた試験をします。その試験の中で衛星の打ち上げ環境に対する耐性を確認して、ようやく衛星として完成ということになります。次に射場に持っていって最終整備準備を整えて打ち上げとなります。
One critical part and critical stage was the transportation. Went through different transportation means. It went through the land, sea, and air. Transportation starts from Kamakura by land to Fujisawa, and from Fujisawa departure by sea to Nagoya.
以上です。途中で不明な点ありましたら挙げてください。思いついた方からよろしくお願いします。
Then we have the last step, which was the air transportation from Nagoya to Florida. When it comes to the air transportation, it was important to find the reliable transportation mean, and the decision was made by a special plane, the well-known, the Antonov, due to the size of the satellite, to take the satellite to the launch site.
What step we take to ensure that the launch will go smoothly? We pray a lot. But in reality, I think is we have done a rigorous process in terms of manufacturing, in terms of testing, in terms of integrating and testing the integration with the rocket itself. And I think that we have done what we can do in this regard.
アメリカに来てからおよそ約1ヶ月かけて衛星のチェックを終わりました。日本から我々の社員エンジニアがここフロリダの地で約30名ほどで作業を行いました。
During the selection of Milco, we have studied different launchers. Each manufacturer has their own satellite platform, and this platform will decide the launcher. Depends on the size, it depends on the weight, and depends on many aspects. So this is why we have decided to go with the SpaceX, because SpaceX, again, it's a reliable launcher and it has the technical interface with the satellites.
liftoff. Falcon 9.
So we just have one more security checkpoint. We're on the bus maybe another 10 to 12 minutes. And then it'll become very evident to you that we have arrived at the launch pad because you will see the rocket on the pad. So very excited to have you all. So glad that you could join us. We know that you've come from near and far, so we're really excited to put together a wonderful day.
Underneath the landing legs are the 9 Merlin engines. Each Merlin engine puts out 190,000 pounds of thrust. So the entire rocket is 1.8 million pounds of thrust. That's a lot of thrust pulling up on the launch pad. Just to give you an idea on the relative thrust, I mentioned 1.8 million pounds of thrust. The airplane that you flew over here has about 50,000 pounds of thrust. So 1.8 million versus 50,000. Very powerful to get this rocket going at enough speed to get into orbit and get the satellite up into geostationary transfer orbit.
Weather balloons are released about every 10 minutes, and we saw some thick clouds and some cumulus clouds, but those have cleared and weather is go for launch.
The Air Force is actually very good at predicting where the clouds are going to be where. So in the past launches, there may be, a 1 kilometer opening. They'll time it exactly right. They'll predict it, out an hour or two, and we'll launch right through the clouds. Right now, we're still okay for the beginning of the window. We have 2 hours. Window. A little less than 2 hours, hour and 50 minutes. For your viewing, actually, clouds are better because you get a lot more sound energy. Yeah.
You get the effects.
Yeah.
Of course, when you are running a satellite program, you have all the time in mind that there is a risk at any step that you are undertaking. So that's why you do a lot of testing. You understand all the time that there are launch failure risks. Soyuz launch failure also reminded us that there is all the time a risk with a launch. Especially the Soyuz is one of the most reliable launchers.
32 minutes.
32 minutes.
Yes, from liftoff to spacecraft separation.
Yeah, فيعني في خلال 32 minutes all of us will be very near Earth.
Yes.
Yeah.
And then 20 minutes.
32 minutes for SpaceX. But for us, it's 55 minutes.
Yeah.
To be in orbit. To be not in orbit.
To make sure the house.
To acquiring the signal from.
To contact the satellite.
To contact the satellite.
To be in orbit.
Almost. Because it's a couple of days, but we're not taking to the orbit immediately, because we're taking to different orbit to do the test, and then we're moving to the orbits.
Raise your hand if you've seen Star Wars. All right, Star Wars. Anyone remembers Han Solo's ship from Star Wars? What was his name?
Millennium Falcon.
Millennium Falcon. All right, we're a bunch of space nerds at SpaceX. We like the Star Wars movies. We took the name Millennium Falcon. We took off the Millennium. Falcon became the name of our rocket. 9 engines means there are 9 engines on the bottom of the first stage. My suggestion to you, and most of you will ignore my suggestion, is to put your phone down, try to be in the moment, take in everything that's going to happen over the next 55 minutes. And what you're going to see, if you're in the moment, T-minus 0, you'll see the engines light up, and it's going to be quiet, right? You expect to hear a loud explosion. You won't hear much. And then you see the vehicle lift off the pad, still quiet. 10 seconds go by. You see it go further and further. And the noise grows and grows and grows and rumbles. And finally, you'll be able to feel the full effect of the vehicle. And it sounds like it's ripping through the atmosphere. You'll be able to feel it in your chest. It's much more enjoyable when you do a countdown. So I don't know if His Excellency would like to lead us in the countdown at T-minus 10 seconds, and then we all join in the countdown until we hit T0 at liftoff. At 1 minute before, we pressurize the tanks. And then at 3 seconds before launch, we light the engines, full thrust. We have these giant clamps that hold down the vehicle, right? And what we do is we do a full system test. Thousands and thousands of parameters are checked. If everything is green and okay, we release the clamps, and the rocket goes up. If any one of them is off, we shut down the engine and we try again. It is not unlikely to get to T0 and have an abort. All abort means is that we're going to shut down the engines or we decide to go check something and come back. That is not uncommon. That doesn't mean that your spacecraft is in any sort of harm. I just want to set expectations that it could happen. Hopefully it won't.
And Falcon 9 is on internal power.
15 seconds before the launch, my heart rate is getting fast, and my brain is only with the rocket now. I am praying God to conclude this operation successfully.
Ground gas closeout's complete.
Falcon 9's in startup. Stage 2 press for flight.
Go for launch.
Stage 1 coming up to startup pressures.
Minus 15 seconds.
Falcon 9 configured for flight.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition.
And we've had max Q, so again, decreasing pressure on the vehicle as we continue to ascend the thinner parts of the upper atmosphere. And we're coming up on a sequence here where a few events will happen in very short succession. Those events are MECO, stage separation, and then SES-1. Those stand for MECO, main engine cutoff, stage separation, and then SES, which is second engine start number 1, the first of the 2 planned burns today. And those are, MECO is when we shut off the 9 Merlin engines of the first stage, and then once we've shut those down, we separate the 2 stages, and then once the stages are separated, the second stage engine, the Merlin vacuum engine, is exposed to space and it will begin burning. That will happen over the span of about 10 seconds, starting about 20 seconds or so from now. Again, main engine cutoff, stage separation, second engine start.
It's separation, it's going 10,000.
MECO has stage separation.
Stage separation confirmed.
SpaceX start celebrating their successful launch. I told them, listen, don't celebrate now, please. Let's wait until we hear from our people in Tokyo, our people in Japan, because they have 32 minutes to celebrate, but we need another 55 minutes to celebrate. Their celebration is different than our celebration. Their celebration is with the end of their process by having the rocket return and by injecting the satellite to the orbit, but our success was completely different. We have to wait until the response between the satellite and the ground. We have to wait until the solar array deployment. And even after, until today, until let's say, until 3 weeks after the launch, I was worried about the test, about the communication, about the health of the satellite.
Second engine start.
And we've had second engine start number 2 as that Merlin vacuum engine relights, which is not an easy feat to do out in space, to relight a vacuum engine like that. Now this burn will last for a little bit under a minute in total. So we're gonna burn through about T plus 27 minutes and a half or so, at which point we'll reach SECO 2, or second engine cutoff number 2.
And that cutoff.
And second stage has concluded its second and final burn for that second stage as it delivers SHALE-2 to geostationary transfer orbit. Now what's gonna happen here is we're gonna coast for another 4 or 5 minutes or so, just like we coasted between first and second. We're gonna coast between now and the actual deployment of the payload in its correct trajectory.
Spacecraft separation confirmed.
And there it is, a beautiful sight as SHALE-2 floats away again
Also
to provide
signal Gabon, as
communications
expected.
from geostationary orbits. Today was a wonderful day.
Qatar is trying to convert from hydrocarbon-based economy to diversifying its economy. This is where we see, and I see, SHALESAT can contribute directly to Qatar 2030 vision. And the other aspect, SHALESAT is contributing directly to the human capital building. In SHALESAT, we have invested in our human resources. We have invested in Qatarization. We have sent a group of engineers in both programs, SHALE-1 and SHALE-2, with the manufacturers, and they were deployed in both programs, and we feel they are the future of SHALESAT.
My name is Ibrahim Abdullah Al-Haj. I'm a satellite project director. I've been with the company since the beginning. I was one of the trainees when I started as an engineer for the company with the first satellite SHALE-1, and now I'm part of the project team for SHALE-2.
It's been almost now a year and a half, 2 years we've been here, and we're trying to learn every aspect of the satellite through the engineers, which expose us to a lot of information about the satellite.
I study electronics engineering with space systems. I'm very grateful for SHALESAT for providing me this opportunity to study this 4 years course in the prestigious University of Surrey. My motivation is when I graduate, I go back to SHALESAT and get some work experience and work alongside some experts. Then I will travel the world and get more experience to help my country.
I'm really grateful to SHALESAT company to give me the opportunity to study the thing I love, and also opening the door to other young kids who also fell in love with the same thing I did. What gives me the motivation to study this program is that I'm going to be able to help Qatar achieve their visions of Qatar 2030.
SHALE is a star. When the star appears in the sky, the people in Qatar and this region get happy that the weather has changed, and always optimistic that the sail star appears in the sky. We start thinking now, what's next? I believe now we have covered the MENA region. We have met the two objectives of commercial and strategic objectives. Now we need to expand and grow outside MENA. SailSat, we believe in partnership. This is why we are looking for partners who can help us grow and again expand our service and our presence globally.